This chapter is about areas. Pretty straightforward, I think. I feel like you guys should probably like this one a little bit more than formal. Do you guys know what area means?
Area.
Has something to do with the inside of a shape, yes. What does it tell us about the inside of a shape? Yeah, let's start with okay. Let's start with the rectangle. Okay, let's say that there was this town that was like rectangular in shape, and these are like the city blocks. How many city blocks are there?
24.
How'd you figure that out so fast?
4 times 6.
Right. There's 4 rows, or yeah, 4 rows and 6 in each row. Or you could say there's 6 columns, 4 in each column. It's just 4 sixes or 6 fours. So yeah, there's 24 city blocks. This is also how you find area. Area is measuring the size of a 2-dimensional space, a flat surface, using square units. What do I mean by square units? Well, it could be square inches. This is bigger than a square inch, but square, guess, how would you measure the size of your house?
Square feet.
Square feet. The size of this room would be square feet. Before they had the carpet, you guys remember the tiles? They were a square foot. What's a square foot look like? Okay, what's a foot look like? That's too long. About like that. What's a square foot look like? No, neater than that, but it's kind of rectangular there. Square foot looks like it's 1 square by 1 square. 1 foot by 1 foot square. And you could also have a cubic foot, which we're not really doing in this chapter, but it'd be, a 3-dimensional cube. But yeah, square feet is what we use to measure the size of kind of a nice little house. Might be 1,500 square feet. Okay, 1,500. That means 1,500 of these things would cover the floor. What would we use to measure like Oklahoma or Washington County? Square miles. Yeah. Of course, if you're like in Europe or something, they probably use what? Square kilometers,
Yeah.
square meters, square centimeters. But yeah, they use squares. So to find the area of a rectangle, basically what do we have to do? This times this. What's this and this called? What could we call this?
6.
6. Now this is the same as that, right? So when I point at that or that, these two sides are the same on a rectangle. So what is this side called?
The base.
Okay,
Width.
it's either called the base or sometimes it's called the length. I think the book might use both, but on a rectangle it can be base or length. So it's either base times, what's this called? Height, or sometimes it's called length times width. So whatever, you just multiply the 2 dimensions together. That times that. Pretty straight. So, and the way you would label this is 24, let's pretend this was like inches, even though these are bigger than inches. 24 inches squared, because this is a normal inch. Okay, this is not an inch. A square inch is that. So to differentiate between just 24 inches and 24 square inches, we put a little square on this. So we're not just talking about 24 inches, We're talking about 24 square inches. Got it? So most of the answers on this chapter will have a little square. Now if I was talking about perimeter, would the perimeter be inches or square inches? Inches. It's this length and this length and this length, and if we put it all together, just make a straight line. So the perimeter is just a length, just a normal inch or inches. We're talking about area. Okay, so we're doing rectangles today, but we're also doing parallelograms. How do we find the area of a parallelogram? Doesn't look very parallel. It's better. Perfect in every way, am I right?
Line one side and the rest are the same.
No, parallelogram doesn't mean all the sides are the same.
Oh, I mean,
Okay, here's the thing on a parallelogram. If I took the scissors and cut this straight down over here and transplanted it over here, what would I get?
this rectangle.
Yeah, turns into a perfect rectangle. So what would the area be? It'd be this length, which is the same as this length. So base times this height. Is this height the same as this?
Yeah.
No.
Is this the same as that? No. So if they give you a number over here, that's not going to help because that's not the height. The height is the line that goes straight up and down. This line is longer than the height, this one. So anyway, it's base times height again, but the height is the vertical line, not the side of the parallelogram. So base times height again. Okay, what if we had square? What's unique about a square?
All the sides are the same.
All the sides are the same, so what would its area be? Remember, a square is a rectangle, right? Because it has 490 angles. So it's the same as a rectangle. It's base times height, but the difference is the base and the height are the same. So how could I write this? These are S's, not 5's. Side squared. One side times itself would be the area of a square. It is base times height still. It's just, you can write it a little bit differently. S stands for side in this case. Okay, and then last but not least, and there's probably the ones you missed today will probably be these. Triangles, we're also doing today. I don't know, when's the last time you guys talked about like area of a triangle? Maybe 7th grade? Did you do it in 8th grade? No? Possibly been a long time. I know you did in 7th grade. Well, a triangle turns out if I like double this triangle and flip it over and like stack them on top of each other, guess what shape it makes? Parallelogram. So a triangle turns out half of a parallelogram. Like this is, I'm not gonna prove it. We're just gonna say it's true. So how did we find the area of a parallelogram? Base times height. So how am I going to find the area of a triangle that has the same base and the same height?
Base times height, divide 2.
Divide by 2. Okay, so really everything we talked about, squares, and by the way, a rhombus is a type of parallelogram too, right? Rhombus. So it is base times height as well. So squares and rhombus, rhombi, parallelograms, rectangles, all of them, even though I wrote them a little bit differently sometimes, are base times height. But when you get to a triangle is half of a parallelogram. By the way, everything above here, those were all parallelograms. Squares and rhombus and rectangles are all parallelograms, base times height. But a triangle is half a parallelogram, so you have to divide by 2, or times a half. I think the book probably writes it like this. But it's probably easier to plug in the calculator like that. All right, clear as mud.
Yeah.
made up of square units, and squares don't really fit in here. How does that work? You guys thought about that? Like maybe a square fits here, but what about this little area right there? You know what I'm saying? No? Maybe not. Well, basically if you add all the areas together, you'll get pieces of a square, and it still works. So later on we're going to be doing area of circles. Squares don't fit in circles very well, right? But basically if you add all the parts together, that's how many squares it would make. So sometimes the answer will be like 13.9315 squares or something like that. So you just get pieces of squares to find the area. If I wanted to find the area of this room, how would I do it?
Figure out the base and height.
Okay. Probably call it the length and the width because it doesn't really make sense to call when it's like on the floor to call one side of it the base. Yeah, you'd find the length and the width and you just multiply it because it's basically a rectangle. It's not a perfect rectangle, but close enough. So you guys are going to have to do that today on like number 19, I think. This only goes 16 feet, so it's not long enough. So you and a partner.
This is a partner assignment?
No, just on that 19. I was debating whether to give Madeline a hard time. Madeline's got Caleb.
What?
What? Never mind, Caleb. Go back to sleep. All right. Anyway, yeah, just partner up. You need two people, so it's not going to stretch the full length of the room. So you're going to have to like measure it to like here or something and then like measure the rest of the way and have them together. Anyway, just get a close ballpark figure on that one. Okay, you guys ready? This is going to go pretty quickly. There's not a lot of tricks. Number 1, how do I find the area of that rectangle? 15 times 6 is?
That'd just be
90. Okay, how should we label it? I do want you to go ahead and label this. So, feet squared. Feet squared. It's called, the reason the little 2 is called squared is kind of comes from this. It's called a square foot because it's 1 foot times 1 foot is the area of a square foot. Anyway, hey, let's keep going here. Number 3. Okay, I wish on 3 they would have put a little like 6 on the side of the parallelogram. But how do we find the area of a parallelogram? Base times height. So they just gave us the height. It's 5. So it's just 7 times 5, which is 35. What?
Inches squared.
Inches squared. Number 5. How could we find number 5? What kind of triangle is number 5? Isosceles, yeah. So a trick that we're going to need later, I think it's maybe like Friday, but still. On isosceles triangles, if you draw the height in there, it's the altitude in there, it's going to split the base directly in half. We don't really need that today, but we will need that later. Because isosceles, you can create 2 equal triangles. Anyways, how could I find the area of number 5?
Or would you do
Huh? 8 times 6? No. Oh, well, actually yes. But Okay, what was the triangle formula again? Base times height divided by 2. So what's the base?
12.
Okay, now we could use like 10 for the base, but we don't have the height from that base to the opposite vertex. We do have the height for the 12 to the top though. So we use 12 for the base and 8 for the height. So it's 12 times 8 divided by 2. Keziah said 6 times 8, which would have worked. Why would that have worked?
Because that's half the.
Because if you divide like 12 by 2 on the front end, you get 6. Is that what you were thinking? Or you just got kind of lucky.
I don't know.
Anyways, 12 times 8 divided by 2, which is the same thing as 6 times 8. So it's 48, what, meters squared. Most of the rest of the world uses metric system. I think in England they mostly do, but I think they still know what a foot and a mile is. That's where our measuring system, feet and miles, that's where it comes from, England. All right, anyways, 7, find the area of each shaded region. Uh-oh, trouble. Any bright ideas on 7?
Multiply them all together.
Already ready? No, definitely not.
Add them all together.
3 separate squares.
Okay, split it up into smaller rectangles. Did I get all that right? Okay. So if I cut it up into smaller rectangles and then find the area of those rectangles and add them together. So there's more than one way you could do it. You could do it like vertical here, or like horizontal. I'm gonna go, let's go vertical here. Okay, so what would the area of this rectangle right here be?
14.
Right, it's 2 by 7, so that would be 14. This is a harder question. Well, let's go over to this thing. Now the way I drew it looks like a square, but that's just because I didn't draw it very well. It's supposed to look more like okay, I know the base is like 4, but how do I find the height there?
You do 5 minus 7 minus 5.
Right. The height of the whole thing, if you think of this like a building, is 7. From here to here is 2. From here to here is 3. What's that leave from here to here?
2.
Right. 7 minus 2 minus 3. These 3 heights together have to add up to 7, right? Because 7's the whole way up. So 2 plus 3 plus what equals 7? Or 7 minus 2 plus 3 is 2. So what would the area of this little thing be? 4 by 2 rectangle, so it's 8. Okay, similar trick for this. How tall would this rectangle be from here to here?
That'd be like 5.
3 and 2.
That'd be like 5.
5. Or you could say 7 minus 2. How long is this rectangle right here? How'd you get 8?
Wouldn't it be 6?
Okay, well, actually, it's 12 minus 4 minus 2. Yeah, because of this guy. So yeah, so that leaves 6. So how big is the rectangle in the middle?
It'd just be big.
6 by 5, 30. By the way, have you guys seen this notation before? This is 6 feet. This is used for like construction or something. 6 feet by 5 feet. And it's just like describing this rectangle. You guys have heard of 2 by 4? It's a common building material. I'm drawing too big. It just means the plank of wood on the end of it is 2 inches by 4 inches. Okay, the wood is still like long, it stretches into the third dimension. Now this is what the end of the wood looks like, 2 by 4. Used for building. And you could write that like this. Anyways, so the total area of this shape is all 3 of these areas added together. 3 little rectangles. So what's 14 plus 30 plus 8? 52 square what? Millimeters? That's pretty tiny. You guys know how big a millimeter is?
Like a pinch.
So it's about as close as you can get your fingers together without them touching each other. It's the tiniest measurement on the ruler, the back side of the ruler. It's like the width of a penny. Let's see, number 9. How about number 8, even though that's an even? So we're just supposed to find the area of the shaded region. Any ideas how we could do 8? There's an easier way and a hard way.
Lines down the sides. of
Okay, you could draw lines, that's not the easy way.
the loop.
Yes. So she said you can do base times height of the big rectangle, find its area, and then do minus the base times the height of the little square in the middle. So just take out the area of the hole. Does that make sense? So you do the big rectangle minus the little big rectangle area minus the area of the little hole in the middle. All right, number 9, complete the table describing squares with side length S. So how do we find the area of a square? One side times itself, right? Because the sides of a square are the same. So base and height are the same thing. So just take that times itself. I don't suppose on number 9 you guys know what 15 times 15 is. That one's not in our times tables. 15 times 15. 225. That's in yards. For the labeling, if I remember, I'll give you all a point if you label most of your problems. So just do that. Or I'll take off a point if you don't. Number 11. So on 11, they don't tell us what the side is. They just tell us the area of the square. So how do you find, if the area is 324, how do we find the side length? No. Right, what's the opposite of squaring? Square root. So what is the square root of 324? 19? 18. 18. Should that be feet or feet squared? Feet. Why did we switch to feet? Because we're just talking about the length of the side on this one, like a length, not an area. All right, 13. So 13 it says complete the table describing rectangles with base B and height H. So how do you find the area of the rectangle? Multiply, right? Base times height. So 3 times 12 for number 13 is 36 inches squared. Okay, 15. They give us the base, they give us the area. How do we find the height? Yeah, so 27 times the height equals the area of 405. So how do I figure out what the height is here? How do I solve this for H?
You divide.
Divide. If If you multiply forwards to work backwards, you divide. 15. And this should just be 15 what? Meters. Plane meters. Easy peasy, Japanesey. Okay, find an area of the following. A triangle. What's the area formula for a triangle? You gotta divide by 2. Don't forget that one. I get it wrong on number 6. On number 6, by the way, so if it's a right triangle, the side of the triangle is automatically the height because it's going up at a 90-degree angle. So keep that in mind. All right, 17. So the base is 56. The height is 24 centimeters. So 56 times 24 divided by 2. What does that come out to?
6 centimeters.
And this one was centimeters. Oh, wait, 19 was the one I said you guys can do with a partner. Everybody know how to use a tape measure?
Yes, sir.
If not, I guess you can ask. Okay, 20 you can skip because it's a bedroom. And first off, I don't know how to grade it. Second off, you might not have. You guys probably have a tape measure at home, but don't worry about 20.
Just be loud.
20.
21 still.
Oh, it's 21, not 19. So we need to go back and do 19. 19 is a square with sides of 2.5. So how do I find the area of a square?
Just
One side times itself. 2.5 times 2.5. 6.25 meters. Okay, so 21 is the classroom one. 23 I skipped also, so I guess we're skipping 20, 23. So 24 and 25. All right, it says find the area. So we need like a base and height. Trixie. Any ideas on 25?
No.
Well, we need the base and the height, right? Because SR is like straight vertical and not like a slanted thing like QR, SR would be a much better base for this one. So how long is it from S to R? How far is it from 2, -4 to 2, 2? Whoops, what am I doing? 2, -4 to 2, 2. This will be our base.
Oh, we're on 25. I was lost. Lost.
How far is it from there to there? Okay,
Just 2.6 or 0.6.
well, no. The length is not 2 coordinates. The point is 2 coordinates. These points are 2 coordinates, but this length is only one number.
So you got the distance or something.
Yeah. How far is it from here to here? Well, because it's straight vertical, you can just count, right? Like 1, 2, 3. Well, how far is it from 2 and 2 are the same on the x coordinate, so it's just the y value is changing. How far is it from 2 to negative 4?
6.
6. From 2 to 0, or you could say from negative 4 to 0 is 4, from 0 to 2 is 2. Or you can just think of it like 2 minus negative 4. Anyway, the length is 6. We'll say that's the base. How could I find the height, though? See if I can draw this kind of decent. Not really. So I need, how far is it from there to there? So if I'm going like straight across, what value measures straight left and right?
The X value.
The x value. So really I need to figure out, for how long this is, how much are the x values changing from here to here? Over here the x value is like 2, right? So what's the x value right here, and then this count from there to 2. So on the left side the x value is at negative 2. So how far is it from negative 2 to 2?
Oh,
4. So the base is 6 and the height is 4. It would have been hard to use the other side as the base. It was possible. You'd have to use the distance formula though. Should have been a mess. Anyways, yeah, 6 times 4 is base 9, so it's 24. I don't think they give us units, so guess how I'm going to label it?
that's crazy.
Units squared. Did I just blow your mind?
What are we actually did? You just keep rolling this.
I think 24 is a little bit easier than that one, hopefully. But you can ask for a opinion, I guess.